Hello everyone and welcome to this presentation entitled L1 and L2 Normal Construction Tomography Process Altered with Adaptive Model Selection Applied to Simulated Targets and Terra SAR X Data. My name is Ishak DAOUD from University of Science and Technology Huawei in Algeria, from Laboratory of Image Processing and Radiation, Faculty of Electronic and Computer Science. Sartomography is a new technique used for Earth monitoring and reconstruction of 3D representation of the Earth. Uses multiple SAR images from different view angles to synthesize an aperture along elevation direction. This technique can be considered as an extension of conventional interferometric SAR that allows for multiple scatters discrimination within each resolution cell. By taking the product of the interferometric SAR and taking off the phase related to the flat Earth and compensate the atmospheric phase delay, we end up with a set of complex interferograms that can be used to estimate the 3D profile of reflectivity along the elevation direction. This technique can provide a new opportunities and solution for many applications and problems, like the problems caused by layover and foreshortening. One of the main constraints of this application is the irregular baseline sampling and the small aperture in baseline, especially for the new generation X-band synthetic aperture radar satellites like Terra SAR X and Tandem X satellites. For the Sartomography reconstruction, several methods was proposed, like the one highlighted in this presentation. And other inversion methods, like slimmer algorithm based on compressive sensing, which represent the main focus of this work. The main goal of Sartomographic reconstruction is to solve the following system of equation. Y is the vector that contains the AM complex interferograms. The X vector represents the reflectivity profile along the elevation direction, and the A represents the measurement matrix, which is primarily depends on the baseline and other parameters. Due to the small number of acquisitions provided and the number of samples to reconstruct, this system of equation becomes underdetermined. The use of compressive sensing can help for the reconstruction of reflectivity profile from the previous equation by relying on three principles: the sparsity of the signal, the coherence of the matrix A, and the restricted isometry property, which guarantees sufficient sparse reconstruction in the presence of noise. In the presence of noise, the L1 and L2 norm minimization is more adequate for this sparse reconstruction. The L2 norm minimization can help to find the best solution in the presence of noise. The second factor is depends on the L1 norm minimization. It's used to promote the sparsity within the solution. In SAR tomography application, the RIP and the incoherence are violated for several reasons. The first is the distortion of the baseline of our measurement systems aren't optimum. The reconstructed reflectivity profile is often sampled much more densely. This is why the reconstructed signal approach the solution but with several outliers. The slimmer algorithm uses the position of the sparse solution from the L1 and L2 norm minimization to shrink the system of equation. Then estimate from this set of positions the false non-significant scatters to finally obtain the most likely number of scatters. After that, Slimmer uses this set of positions to shrink again the system of equation as follows. And finally, estimate the parameter of the signal like amplitude and phase. In our method, a new selection is proposed that started with rearranging the position of the scatters from the most significant to the less significant. Then eliminate the false non-significant scatters to finally obtain the most likely number of scatters. In the following, some result of the map-free tower for the 2D range profile of reflectivity. We did also a 3D point cloud reconstruction of the map-free tower of Barcelona projected into the S-axis. The work presented here doesn't present an improvement method of the slimmer. Instead, it is an alternative method. The resemblance in results is associated to good pretreatment of the data and the good selection of lambda k and the threshold used in second step in model selection proposed. The application of our proposed method require an adaptive noise estimation to better pick the lambda k and better select the threshold for the model selection proposed.